going to talk a little bit more about reference angles. They were part of your homework. I just want to make sure that everybody is on the same page about reference angles, how to find them. Last class, we spent time on Friday going over coterminal angles and making sure you guys understood coterminal angles a little bit more. Okay, and so we're going to spend just a little bit of time today making sure that you guys have reference angles and things like that down before we move on to the next part of the unit. Okay, so reference angle, it can also be represented with the theta and then the apostrophe symbol. Is the angle that is formed by which side of an angle? It's formed by the terminal side of the angle in blank position. What position? Standard. In standard position. Very good. So it's the angle that's formed by the terminal side of an angle that's in standard position and the length. And the x-axis. Very good. Okay? Very good. So you have an understanding of what the reference angles are. Okay? The one thing, though, is that when you're given an angle, the main thing is you want to make sure that it's kind of hard to see here on the board, but it is printed, I think, somewhat clearly on your notes, is that the angle, if it's in degrees, it needs to be in between 0 and 360 degrees. Or if it's in radian, it needs to be in between 0 and 2 pi radians. Okay? Because no matter what, reference angles are always what? They are always positive, but they're also always acute. Very good. Forgot about the positive one. I guess I should put in 2 blanks. So acute, and also put in positive. So if you're originally given an angle that is not positive or is bigger than 360 or smaller than 0, then you kind of want to basically, if anything, if you struggled on this part, you want to try to find a coterminal angle that actually lies in one of the quadrants between these two angles. So then that way you can kind of use these formulas right here to help you find the to actually find the reference angle if this was a struggle for you in the homework. Okay. So if you're asked to, sketch 3 pi over 4 and then find this reference angle. Okay? 3 pi over 4. Where is that located? Where is 3 pi over 4 located? In which quadrant? Second?
Yes.
Okay. Remember, if trying to figure out where the angles actually lie, look at the coefficients. 3/4. 3/4 is less than 1 but bigger than 1/2, correct?
Yes.
So then it would definitely be in the second quadrant. So then this will be the sketch of 3 pi over 4, and then to find its reference angle, since it's in the second quadrant, what I need to do to find? No, not subtract 2 pi. Look at it. It says pi minus theta. Okay, that's how you find the reference angle. So these right here are kind of like little formulas in case you're not quite sure of, how to go about finding the reference angle. If the original angle is in the second quadrant, then it's the distance that's between that terminal side and the x-axis. So how do you find it? The easiest way would to take the positive x-axis of the negative side of the x-axis pi, and subtract the angle from it. How do I subtract the whole number from a fraction? Common denominator. What is the common denominator here?
4.
So pi can be written as 4 pi over 4, and what's 4 pi minus 3 pi? 1 pi. So this would be 1 pi over 4, and then that would be your reference angle. Okay? So as long as the angle is in between 0 and 360s or 0 and 2 pi, then just based on what quadrant it's in, you can go from there. Now it says to sketch negative 150. Well, negative 150 is heading which direction? Clockwise. So since we're dealing with degrees, if I go clockwise and I start at 0 going clockwise, this would be negative 90, because I've gone a quarter of 360. And then here would be what? So negative 150 would be in which quadrant? The third quadrant. Now remember, when it comes to sketching, I'm not looking to see that it's exactly at negative 150. I'm looking to see that it's in the third quadrant. Okay? And then, of course, you put in the curve marking in the correct direction to let me know, to indicate that this is a negative 150 degree angle. Okay? So there's the sketch. that angle is not in between 0 and 360. So how do I find the angle that is between 0 and 360? AKA, how do I find a coterminal angle? I need to what? How do I find a coterminal angle? I need to add a 360 because one, I'm in the negative direction. I want a positive angle. So what is basically 360 minus 150? 210. So 210 is a corresponding coterminal angle to negative 150. And if you can find the reference angle for 210, you found the reference angle for negative 150. In the third quadrant, what do you do? In the third quadrant, look at your chart. You subtract 180 because it's degrees. So what's 210 minus 180? 30. So 30 degrees is your reference angle for negative 150 degrees. Everybody seeing the notation that I'm using, correct? I'm not putting theta. Theta is the original angle. I'm putting theta prime, the apostrophe. That indicates a reference angle. Okay? That's what theta prime is, reference angle. Questions? All right, let's look at that last one. I don't have to sketch it here. I just need to find the reference angle for 520. Is 520 in between 0 and 360?
No.
So how do I find the angle that is between 0 and 360? So 520 minus 360 is 160. So 160 is in which quadrant? The second quadrant. So if you're curious, like, okay, so how is 520 actually drawn? That is with one full time around and then going another little bit to meet up with it. That's 520 degrees. It didn't ask to draw, but for those who need the drawing to see it, there it is. It is in the second quadrant, so that means I need to do what to find the reference angle? Subtract that angle from 180, and what's 180 minus 160? 180. So the reference angle is 20 degrees. Yes?
How do you know how many times you're going to go on?
Well, for one, look at the angle itself. If it's bigger than 360, only one time, that means you have to go a full one time all the way around to represent 360 degrees. So then the remaining 160 is what gets you to the actual angle itself, or the actual terminal side itself. Okay? So when it comes to the sketching part, the drawing part, you yourself have to think, okay, degrees is, of course, a lot easier than radian. Okay? So you'll have to take a look. How many times bigger is it from 360? Is it only one time and a little bit more? Two times and a little bit more? Because that many 360s is how many times you go around. Okay? When it comes to the radians, 360 degrees is what is a radian? 2 pi. So then you have to see, okay, like how many 2 pi's are within that particular radian. So if I give you 19 pi over 4, and I ask you to sketch this angle and find a reference angle for it, you have to ask yourself, is this bigger than 2 pi? Yes, it is, because technically 2 pi, so that it has a common denominator of a 4, is technically how many pi over 4? 8 pi. 8 pi over 4 is 2 pi. 19 pi over 4 is bigger. Okay? So I already know that I'm going around one time for sure. Okay? If I added another 2 pi, that's another 8 pi over 4. What's 8 pi over 4 plus 8 pi over 4? 16 pi over 4. So then it's still not 19 pi over 4, correct? So that means I have to go around another time. So everybody see that? Now, how far away is 16 pi over 4 from 19 pi over 4? 3 pi over 4. And 3 pi over 4, we just did it, is in what quadrant? The second quadrant. So your terminal side is in the second quadrant, and and we have the remaining 3 pi over 4 to go. So this right here would represent 19 pi over 4 when it comes to the drawing. And that's exactly how many 2 pi's you would subtract to get to an angle that's in between 0 and 2 pi. I need to subtract 2 pi twice because I went around 2 times. So 19 pi over 4's coterminal angle is 3 pi over 4. And since it's in the second quadrant, my reference angle is going to be what? Pi over 4. How'd you get pi over 4?
Sorry. We subtract pi from 3 pi.
Very good. So then common denominator. And you get pi over 4.